The next advanced class design topic we're going to discuss is the keyword and concept of static. So in order to discuss static, let's do a little review of variables. So we've talked about a couple different kinds of variables: instance data variables and local data variables. Local data variables are variables that are declared inside of a method. So remember that what matters about variables is where they're declared. So that very first time you specify the type and the name, that's the declaration, and where that happens determines what kind of variable it is. So for local data, the declaration happens inside of a method. That means that that data variable can only be used in that method, and that it means as soon as the method ends, the variable is garbage collected. Okay, so local data is really local only to a single method. Now, instance data variables, on the other hand, are declared inside the class. So they're declared outside of any particular method, but inside the class. That means they can be used anywhere in the class. So they can be used in any method within the class. It also means that they stick around and are kept as long as the object is kept. So an instance data variable persists as long as the object lives. And that instance data variable is associated with the object. So remember that instance data variables represent characteristics of an object. So they're what describes the object. Now, because of that, every object you create gets its own version or its own copy of every instance data variable. So if your class is student and you have 10 student objects, and let's say the student class defines a first name, a last name, and an email address as characteristics or instance data variable that describe student objects, each individual student will have their own first name, their own last name, and their own email addresses. So if you have 10 student objects, you'll have 10 different first names, 10 different last names, 10 different email addresses, one associated with each object that you create. So that's really the most important thing to keep in mind about instance data variables, is that there's, again, one version for every single object you create. Now, when you want to change or update an instance data variable, you do so. We keep our instance data variables private. So every object has their own copy, but they're private. So to change that value, you have to invoke one of the public methods, usually called setter methods, on that object. So if you have, again, a student class and you have an instance data variable first name, let's say you have an object called student1, you would change this first name instance data variable by invoking the public setter set first name and passing in the new information as a parameter. So this is invoking a setter to change this instance data variable about this object. So again, the key thing here is that the instance data variable describes the object. So there's a version of that instance data variable associated with every single object. Now this is quite the opposite of static variables. So static variables, which are also called class variables, are not associated with any object or with any single instance of the class, but they're associated with the class itself. And that means there is only one copy, one version for the whole entire class. So if you, again, have 10 objects, each of those objects will have its own version of every instance data variable. So you'll have 10 first names, 10 last names, 10 email addresses. If you have a static variable, you get one variable. If you have 10 objects, if you have 100 objects, 1,000 objects, it doesn't matter. You only have one static variable. Okay, so that variable is shared across the entire class. It's associated with the class itself, not with any object. So I should say it's shared across every object of that class. Again, it's associated with the whole class, not with any individual object. So there's only one version that exists out there that is shared by all objects. So here's an example. Let's say we wanted to keep track of a count of the number of students that we'd created. Well, it doesn't make sense to have that count associated with any individual object, because each student object only knows the information that describes itself. It knows its own first name, last name, email, whatever else you have, but it doesn't know anything about other students, right? Each object only knows about itself. So if you want information that's shared across all student objects, like let's say you wanted to keep track of a count of how many students have been created, you need a variable that's associated with the class, that's shared across all objects. Okay, so you could create that variable like this. It's a static variable, call it number of students, and now this would have one single count, and that count would be shared across all student objects. So again, if you have 100 student objects, you're only going to have one variable keeping track of a counter, and that variable is shared across all objects. Okay, that means that if for some reason you update this variable through a particular object, which you are allowed to do, that value will change for every other object too, because it's the same variable. There's just one variable. So when we picture our memory picture where each object has its own space in memory, and at that space in memory there's a whole area set up for all the instance data variables, and we have one of those for every object. There's a whole separate place where there's just one little space for a static variable. And again, it's just stored once, and every object, every student object in this case, can access it, but it's just one shared variable. So because it's a shared variable and it's associated with the class, not through any object, you reference that variable through the name of the class. That should be student, not students. So if, for example, you had a number of student variable, you might have a static getter for that variable, and you would access that through the name of the class, not through any particular object. Again, static variables are different because they're associated with the class, they're not associated with objects. And again, changing that value changes it for every object because there's only one variable. So let's say here you had your constructor for the student class. You might put an increment statement saying student.number of students. So this is the static variable, and you might increment it. That means that every time you create a student object, this variable is going to be incremented. So it'll keep an accurate count of how many student objects have been created. But again, it'll keep just a single count across all student objects. So this is similar to static methods. So let's again take a step back and talk about invoking non-static or instance methods. So remember that most methods are invoked through an instance of a class. We create that instance with the new operator, and then when we want to invoke a method on that instance, we use the dot operator. So for example, we create a scanner object and then we invoke next line. We create a die object and then we invoke roll on that object. So these methods are invoked on a particular object that we've already created by using the dot operator. So it goes object, dot operator, method, right? Object, dot operator, method. Static methods are different. Again, just like static variables, static methods are associated with the class, not with any object. So they're invoked through the name of the class. Now you've actually seen some static methods such as math.squareRoot, math.random. You're invoking this method through the name of the class. You never create a math object, right? We don't say math m gets a new math and then invoke m.squareRoot. We just invoke it through the name of the class, math.squareRoot. So you never even need to create an object. You just invoke that static method through the name of the class. Okay? So static methods really, they're kind of more like functions associated with that class. They shouldn't be used to represent an object's functionality. So if you have methods or functions that you want a student object to take, you wouldn't make that method static because that should really be associated with a particular object. But if you have an action that's more associated with the whole class, then that method could be made static because again, it's associated with the whole class, not with any instance data, not with any individual instance of that class. So again, if an action represents an object's functionality, something an object can do, or an action that can be taken on a particular object, then you would not make that method static. But if that functionality is associated with the whole class, then you might want to make it static. Now, if a functionality needs to access instance data variables, you absolutely cannot make it static because remember, instance data variables are associated with a particular object. Static methods are associated with the class. Another good rule of thumb that you can use is think about whether it might make sense to invoke a method before any objects were ever even created of that class. If it does make sense to call that method, then that's a good indicator that you should consider making that a static method. If that doesn't make sense, if you think, no, I really need objects for this method, then it's probably not meant to be a static method. So again, here's an example of a static variable, and then here are static methods, in this case a static getter and a static setter. So the general structure of these look just like a regular getter and setter, except they're static. And again, that means they're associated with the whole class. So getting the number of students that have been created or setting the number of students that exist, these things are associated with the student class, not with any individual student object. And it does make sense that you could invoke both of these methods before you'd ever even created a student object, right? Like it would make sense to say, hey, tell me how many students there exist, and the answer would be 0. That makes sense. So that's another clue that maybe this is a good candidate for a static method if it kind of makes sense that you could invoke it before you've ever created any objects. So in order to make a method static or a variable static, you use the static keyword, okay? And again, starting to sound like a broken record here, but this is the most important thing about static, is that it's associated with the class, not with any object, and there's only one copy, one version shared across all instances, so shared across the entire class. So there are some additional rules you have to know about. Static methods cannot reference instance data variables, right? So that makes sense because, again, instance data variables are associated with objects, and when you're invoking a static method, you're not invoking it on an object. So which object would you use for those instance data variables? There's no way to know. So inside a static method, you can never reference an instance data variable. You are allowed to reference static variables or, of course, create local variables within that method. Static methods cannot directly reference other non-static methods. So you can't invoke an instance method from a static method. Again, instance methods are associated with objects, and static methods are never invoked on an object, so it wouldn't know which object to use to invoke that non-static method. You are allowed to reference or invoke other static methods. So a static method can call another static method. That's okay. If you try to break any of these rules, you will get a compiler error. So this is a little summary chart. We've got static methods, static variables, instance or non-static methods, and instance data variables. Basically, everything can access everything else except here, static methods can't access instance data variables. So an instance method accessing a static variable, this would be an example here. If we had our constructor, which is non-static, and we incremented a static counter, this is an example of an instance method incrementing or accessing a static variable, and that is allowed. The only thing to be cautious about here is that if you change a static variable through an instance method, just remember that that value is changed for all objects, right? So even though you're going to invoke this instance method through one particular object, the value of the static variable is changed for all objects because, again, there's only one version of that variable. Now, an instance method can access instance variables. This is kind of what we've been doing all along. This would be, here's an example, your traditional getter. This is an instance data variable. It's associated with a particular object. If you want to invoke this instance method, you invoke it on that object, and then that's the version of the instance data variable that's used. Static method is allowed to access static variables. That's okay. So if we had a static counter of the number of students, we could write a static getter to access it. You would invoke this method through the name of the class, and so then you would just access the class's static variable inside the method. That is allowed. This is the this is the one that's not allowed. So static methods cannot access instance data variables. What would it look like if we tried to? Well, if we wrote a method getStudentName and we made it static, because it's static, we invoke it through the name of the class. So if we invoked student.getStudentName, well, whose first name should we use, right? We might have 100 student objects, and there's no invoking object here. There's just an invoking class. So we'd have no idea whose first name to get. So it really makes sense that static methods shouldn't be allowed to access instance data variables because they don't have an object to reference, right? So this is the only kind of pairing that's not allowed. So when would you use static variables and static methods? Well, you can use static variables anytime there's shared data. So if you have, example, a count of objects or some sort of total that's summing across all objects, that's shared data. It's data that's shared across all objects. you'd want to use a static variable for that. Of course, I say be careful because remember when you update that variable, you're updating it for everyone because there's only one copy. Static variables are also good to use for shared constant. So you've actually seen these before in some of the GUI classes or in the wrapper classes. All of these have constants. And the idea of making a constant static is that its value can't change anyways. So you don't have to make it static. You could store that constant once with each object that you create. But since the value can't change anyways, it's almost like a little efficiency, right? Why not just store it once because it's the same value for everybody. It's a constant, right? So if you have some constant you're putting in your class, it's pretty standard practice to make it static because then we just store it once. You really don't have to do this because again, it's constant, value can't change, but it's pretty common to make it static. Again, you sort of save yourself from having to store, 100 copies of that value instead of just storing it once. When would you use static methods? Well, logically speaking, you want to use them anytime you're thinking about more of like a utility or a helper function and less like functionality that's associated with an object. Again, another question you might ask yourself is, does this functionality make sense to invoke before any object exists? If so, that might be a good time to use a static method. So essentially anytime you kind of want to send an input and get a result, but it's not associated with functionality of an object. So that's the sort of logical question you want to think about when deciding to use a static method. But also from a programming side, essentially anytime you want to access a static variable or that kind of shared information, that method needs to be static, right? Because that then it's associated with the class just like the variable is associated with the class. So let's take a look at using static in a couple of practices. We're going to look at the audio item class and we're going to keep track of how many audio items exist. So here's our audio item class and I'm going to add a static variable. I'll call it num audio items. Now, unlike instance data variables, it is pretty standard practice to initialize static variables when you declare them, especially one like this where we're going to modify it inside the constructor. If I were to initialize it inside the constructor, it would be constantly getting reset to 0. And that obviously wouldn't really make a lot of sense. So it's pretty standard to see static variables initialize with an initial value right when they declare them. Again, this is different from instance data variables. Now, static variables can follow the same rules as other variables, meaning I'm going to keep it private. I don't want another class to be able to directly access this variable. Just because it's static, it doesn't change that aspect of it wanting to keep it encapsulated. So that's where I declare it. Now I'm going to increment it inside the constructor. So here I increment a static variable inside of a non-static method. If I want to get particular about it, I could put audio item dot num audio items. This is usually a good idea to do because it kind of cues your reader in that, oh hey, this is a static variable that's shared across all objects. You don't need this. Your code will compile without it. But again, it's not a bad practice to get into because it's a good visual cue for someone looking at your code. So this will now keep track of the number of audio items. Of course, if I want to access this variable outside of this class, I need to make a public getter for it. And again, I'm going to make this static because it's accessing, it's a getter for a static variable. Now, I could also make a setter, but for this case, I don't think I want to allow direct access to be able to set that number. I only want it to be able to be incremented when an audio item is created, because that'll allow me to keep an accurate count. So I'm not going to provide a setter, but there's nothing about the fact that this is static that prevents me from providing a setter. It's more just that for this particular variable, it doesn't make sense. So now if I go into my tester program, I've created some items. I can say something like, so far there have been, and I would say audio item dot get num audio items, items created. So again, here I'm accessing a static method through the name of the class rather than through the name of any individual object. So here it'll say, so far there have been 2 items created. Now, just to go back to give you a little example here, if for some reason I had wanted to access title, I can't do it. And it gives me a compiler error saying cannot make a static reference to a non-static field. And again, that makes sense because look at how I'm invoking this method. I'm invoking it through the name of the class, but which title would I use? Would I use this title or that title? Like there's two titles that exist, so I have no idea which one I'd use because there's no invoking object. So again, it really doesn't make sense. If I had some other static method, I would be allowed to invoke get num audio items from that. Okay, so you can invoke static methods from each other. You cannot invoke instance data methods, instance or non-static methods. Again, because there's no invoking object, so which object's toString method would I invoke? I have no idea. So you can only invoke other static methods from inside of a static method. Can't invoke non-static methods. And you can't access instance data variables. Okay. So let's look at one last example. We're going to go over to the audio store account class, and we're going to keep track of how much money has been spent on audio items across all accounts. So again, think about this as shared information, right? There's a total money that's been spent across all accounts on all items. So any one individual account wouldn't have that information, but the class itself can have that information. And again, we can say, does it make sense to kind of ask for this information before any objects have been created? Well, sure. If no audio store accounts have been created, the money spent would just be 0. So that's okay to ask, right? So again, those are kind of some questions to think about when thinking about whether something should be static. So here's our audio store account class, and I'm going to make a private static double total money spent. And again, I'm going to initialize it to 0. Now this time I'm not going to increment anything in the constructor because that's not when money gets spent, but I'm going to go down to my add item method, and here, right, this is where we add a user's add an item to a user's list. So what I'm going to do is I'm going to take out this return for a moment, and I'm going to have a local variable called add successful. So this tells me whether or not that item was successfully added to the list, and if it was, then I'm going to say, well, the total money spent should now be incremented by the balance of that item. And again, I'm going to put my audio store account preface here, so just to remind myself that this is a static variable. It's shared data across all audio store accounts. And then I'll just add back in my return statement. Spelled correctly, of course. Okay, so again, this is a static variable. It's shared across all account items. So if I have 100 accounts and each of them invokes this method, 5 different times, it's going to keep track of all that balance incremented from all the different accounts across all the different items. Okay, and here's an example of having, again, an instance method, a non-static method, and we're allowed to access that static variable. Now I'm also going to add up a static getter so I can access that information. And then again, over in my tester here, I could print that out. And I would access it through audio store account dot get total money spent. Okay, so again, key things to remember about static is that there is one copy, one version shared across the entire class, and those variables or those methods are not associated with any individual object. They're associated with the class itself.